Applied science led to the development of the steam engine. The sequence of events began with the invention the barometer and the measurement of atmospheric pressure by Evangelista Torricelli in 1643. Demonstration of the force of atmospheric pressure by Otto von Guericke using the Magdeburg hemispheres in 1656. Laboratory experiments by Denis Papin, who built experimental model steam engines and demonstrated the use of a piston, which he published in 1707. Edward Somerset, second Marquess of Worcester, published a book of 100 inventions containing a method for raising waters similar to a coffee percolator. Samuel Morland, a mathematician and inventor who worked on pumps, left notes at the Vauxhall Ordnance Office on a steam pump design that Thomas Savery read. In 1698, Savery built a steam pump called the Miner's Friend. It employed both vacuum and pressure. Iron merchant Thomas Newcomen, who built the first commercial piston steam engine in 1712, was not known to have any scientific training. The application of steam-powered cast iron blowing cylinders for providing pressurized air for blast furnaces led to a large increase in iron production in the late 18th century. The higher furnace temperatures made possible with steam-powered blast allowed for the use of more lime in blast furnaces, which enabled the transition from charcoal to coke. These innovations lowered the cost of iron, making horse railways and iron bridges practical. The puddling process, patented by Henry Cort in 1784, produced large-scale quantities of wrought iron. Hot blast, patented by James Beaumont Nelson in 1828, greatly lowered the amount of fuel needed to smelt iron. With the development of the high-pressure steam engine, the power of weight ratio of steam engines made practical steamboats and locomotives possible. New steel-making processes such as the Bessemer process and the open hearth furnace ushered in an area of heavy engineering in the late 19th century. One of the most famous engineers of the mid-19th century was Isambard Kingdom Brunel, who built railroads, dockyards, and steamships. The Industrial Revolution created a demand for machinery with metal parts, which led to the development of several machine tools. Boring cast iron cylinders with precision was not possible until John Wilkinson invented his boring machine, which is considered the first machine tool. Other machine tools included the screw cutting lathe, milling machine, turret lathe, and the metal planer. Precision machining techniques were developed in the first half of the 19th century. This included the use of geeks to guide the machining tool over the work and fixtures to hold the work in the proper position. Machine tools and machining techniques capable of producing interchangeable parts led to large-scale factory production by the late 19th century. The United States Census of 1850 listed the occupation of engineer for the first time with a count of 2,000. There were fewer than 50 engineering graduates in the US before 1865. In 1870, there were a dozen US mechanical engineering graduates. with that number increasing to 43 per year in 1875. In 1890, there were 6,000 engineers in civil, mining, mechanical, and electrical. There was no chair of applied mechanism and applied mechanics at Cambridge until 1875, and no chair of engineering at Oxford until 1907. Germany established technical universities earlier. The foundations of electrical engineering in the 18th included the experiments of Alessandro Volta, Michael Faraday, George Ohm, and others, and the invention of the electric telegraph in 1816 and the electric motor in 1872. The theoretical work of James Maxwell, mainly Maxwell's law, and Heinrich Hertz in the late 19th century gave rise to the field of electronics. The later inventions of the vacuum tube and the transistor further accelerated the development of electronics to such an extent that electrical and electronics engineers currently outnumber their colleagues of any other engineering specialty. Chemical engineering developed in the late 19th century. Industrial scale manufacturing demanded new materials and new processes, and by 1880, the need for large-scale production of chemicals was such that a new industry was created, dedicated to the development and large-scale manufacturing of chemicals in new industrial plants. The role of the chemical engineer was the design of these chemical plants and processes.